Okay, students, so today I'm going to discuss or start with the new chapter that is the humidity. Okay, and a few of the points has been excluded from the syllabus. Okay, and but still I'm going to discuss some of the points and which is very crucial points to understand the further topics. Okay, so let us have a very quick and brief uh, review of the topic humidity. Now, humidity is the water vapor, can be defined as the presence of water vapor in the atmosphere, or the amount of water vapor which is present in the air or the atmosphere is humidity. Now the characteristics of the humidity, if we say, it varies from place to places. It is not same all over the atmosphere or the all over the air. Okay. For example, if you see in the equatorial areas, the humidity is of 4%. But if we go to the polar areas, the humidity is absolutely nil. 0% of humidity is present. Now, why it is so is because of the evaporation. And now evaporation process is directly related with the temperature. Okay, higher the temperature, higher the humidity. Lower the temperature, lower the humidity. Okay, because the evaporation process, if you see here in the equator, we receive the direct rays of the sun. Okay, so because of that, the temperature is higher and the evaporation is also higher, which results in the high humidity. Now in the polar areas, the temperature is low because it receives the slanting rays of the sun, isn't it? So slanting rays of the sun results in the low evaporation, and the low evaporation will result in the low humidity. Okay, so in that way, the humidity and the temperature are indirectly related with it. Now, another thing, humidity is of two types, students. One is the relative humidity and another one is absolute humidity. Okay. Now, again, uh, let us discuss the the different type of humidity also. So, absolute humidity and relative humidity. First, I'll discuss the absolute humidity. For example, a given volume of air is there. Okay, a given volume of air, and the water vapor, the actual amount of water vapor which is present in that particular given volume of air at a given temperature is known as absolute humidity. For example, this is a certain volume of air given to us. Okay, given to us, and here the water vapor which is present right now is 50 gram at the given temperature 25 degrees Celsius. Okay, so this is your absolute humidity, means 50 gram is the absolute humidity of this particular air. Now for example, if you say the room which you are sitting right now, okay, now let's say the room temperature is 30 degrees Celsius. So in 30 degrees Celsius, whatever the water vapor is present in your room right now, that is your absolute humidity. Okay, now the relative humidity. What is relative humidity? Relative humidity is the the ratio between the absolute humidity and the actual amount of water vapor that the air can hold, the maximum capacity of the air. Okay, let's say at this given temperature, the amount of water vapor which is present right now is 50 gram. Okay, but the water vapor which that air can hold is actually 100 gram. The maximum capacity of that air is 100 gram. Okay, but right now we have only 50 gram of like water vapor present. So ratio between that absolute humidity and the maximum amount that the air can hold into 100 is known as relative humidity. Okay, for example, if you say 50 by 100, okay, 50 absolute humidity and the actual amount is 100 into 100, then you have 50%. So right now the relative humidity of this given volume of air is 50%. Okay, and the absolute humidity is how much? 50 gram. Okay, 50 gram of water vapor, 50 gram of water vapor per centimeter cube. This is the unit in which the absolute humidity is measured, and percentage is the unit which the like relative humidity is measured. Okay, now as I have been specifically mentioning, given temperature, isn't it? Why? Because if the temperature fluctuates, then the amount of water vapor, the holding capacity of the air will also fluctuate. Now, more the temperature, the molecules will expand more space will be there, and more water vapor we can add over there if the temperature increases. Now, if the temperature decreases, that means here the molecules will contract more, isn't it? As a result, the space in between the molecules will be less, and less amount of water vapor will be fitted in. Okay, so if the temperature fluctuates, then the relative humidity like will also change. Okay, so next is your will also change. Now next is your condensation. Okay, now the condensation process, or the topic, has been completely excluded from the syllabus, but still I'm going to do that, the topic, uh, a small briefing of the topic only I'm going to do. Okay, so condensation means the process in which the gaseous state will change into the liquid state. That means that water vapor will change into the vapor, means the gas, no, so it will change into the liquid form. This process is known as condensation. So in order to in order for the process of condensation, two important the factors are like really important, that is your relative humidity and the dew point temperature. Now relative humidity has to become 100%, then only the condensation process will begin. Okay, we have thus, for example, over here in this volume of air, we have only 50% of relative humidity. So that means this air or the water vapor over here will not be condensed. Okay, so next is the 100% of relative humidity should be there. Next is the dew point temperature, or the degree of cooling also. Means lesser the temperature, higher chances or the higher opportunity for the air to become 100% of relative humidity. Okay. Now when the air becomes 100%, no, it is termed as saturated air. Okay. For example, the air of the holding capacity of this air is 120 gram. Okay, now exact 120 gram of water vapor, if it is present here, that means this air can be called as saturated air. Okay, so here the relative humidity is also 100%. Okay, and the temperature when the air becomes saturated, that temperature is known as dew point temperature. In which the air will become saturated, it is known as dew point temperature. Now degree of cooling means, as the temperature lower downs, as I said, the more the temperature lower downs, higher chances of the air to become saturated or to reach 100% of relative humidity. Now let's say at 120 like 25 degrees Celsius, the holding capacity is 100 gram. If the temperature decreases to 20 degrees Celsius, then the holding capacity has also decreased 80 grams. 15 degrees Celsius holding capacity is 60 gram, isn't it? The total holding maximum amount of holding capacity of the air is 60 gram. Now when it decreases to 12 degrees Celsius, so that means here it has reached the 50 gram, and the humidity which is present in this air right now is how much? 50 gram only, isn't it? So that means the air has reached its maximum holding capacity. So the relative humidity is also again 100%. So the air has become saturated. Okay, now those that saturated air, no, after the air becomes saturated, then the process of condensation will begin. And one of the form of condensation is clouds, which is formed at the high sky, if you have seen, isn't it? So actually clouds are the condensed water vapor. Okay, so how the cloud formation takes place, let us also have a quick review of that also. So the dust particles, or the pollutant matters, or the particulate matters which are present in the air, also plays a very important role. Without that, the cloud formation is not possible, because those dust particles, or the pollutants, or the aerosols, or the particulate matters acts as a hygroscopic nuclei. Okay, means hygroscopic nuclei around which the water vapor will condensed. Okay, because in order to the for the process of condensation we required some surface in which or object in which the water will condense around. For example, you can take out a bottle from your freeze, isn't it? And the cold bottle take out from your freeze and keep it in the table. Okay, now after some time you will notice that the water droplets are formed around the bottle, isn't it? Now, before the bottle, was there any droplets formation was taking place? No. After you place the bottle over there, now the water vapor has started condensing around. Now, why? Because the in and around that bottle, no, in and around that bottle, the relative humidity has reached 100%. So the condensation process has begun, and the water vapor which was present in and around that bottle had started condensing around in the surface of that bottle. So same thing happens with the dust particles also. Dust particles, the temperature of the dust particles at the higher altitude will be very less, so the water vapor which is present in and around that dust particles will start condensing, isn't it? So when it condense, it will become a small size, it will take off a small size, then another layer of water vapor will also condense around that. In that way it will take a huge massive form of clouds. Okay, and in that way billions and trillions of dust particles are present in the atmosphere, so when they accumulate it with each other they will take a bigger size of uh, condensed water vapor which is known as clouds. Okay, now those clouds will remain suspended in the air, and more amount of water vapor when it's added over there, okay, this clouds will become heavy, and when it becomes heavy it cannot remain suspended in the air further. As a result, it will come down towards the earth's surface. Now the whole clouds will not fall at once. Okay, this condensed water vapor, the clouds will fall on the earth's surface in the different forms. Now that particular process of falling of condensed water vapor on the earth's surface is known as precipitation. And the precipitation has different forms. There are the rainfall, snowfall, sleet, and hailstones. Now, what are those precipitation process? We will discuss in the next class. And the different types of most common type of precipitation is the rainfall. Okay, and the different types of rainfall also we will discuss it in the next class or in the next video. So we will end our video, students, over here. Thank you for watching, and I hope the video was quite. I hope you people have understood. Thank you.